In this video, we're going to document a database as part of a localized initiative. Now, this is the most common use case for ER Studio, and there's three primary steps that we're going to take. So the first one, we're going to connect to the database, and we're going to reverse engineer it and create a physical model. From that physical model, the tool will create for us a logical data model to go with it. And during this process, we're going to see how we can use a naming standards template, where we've taken a series of standards for the way we name our database components and use that to derive new business-friendly logical names. Then the last step, we're going to manually enhance that model with extra information. So again, to explain what we're doing, on the right-hand side of this diagram, we're going to reverse engineer the database and create a physical data model. And that shows the technical metadata within the database itself. So you can see there that table names and column names are using physical naming conventions relevant to the database product. Over on the left-hand side, we're going to create a logical data model from that using business-friendly language. So here we are in ER Studio Data Architect. So we're going to create a new project. We're going to reverse engineer an existing database that we've got on this machine. So we can specify how we connect to the database, either using an ODBC driver or its native connection. We can also store a series of connections within Teams server data catalog. So let's connect. We can select which database we want to reverse engineer. Here is our training database. We can select what types of objects we want to bring in from the physical model. So ER Studio can be used to quite a lot of detail with understanding and designing databases. So system tables, user views, all the way down to roles, schemas. For different database products, we support different functionalities of the database product. Okay, so we can select what objects from the database we want to bring in. So tables, different views, triggers, etc. So we're just going to select everything. Here we can use the tool to help us infer primary and foreign keys. So if the database that we're reversing doesn't have primary key and foreign key constraints, then we can use the tool to actually try and infer some of those based on naming conventions and indexes and such like. When we bring the model in, we can select how we're going to lay it out, in this case orthogonal. The next thing is, what sort of model are we bringing in? Is it relational or dimensional? So we're going to select relational. And then the naming standards template. So this is really important in this demonstration. So the physical names that are present within the physical database, we want to transform those to logical ones. So we're going to use a naming standards template. So many of our customers will create these naming standards templates, which contain a series of mappings of full business terms all the way through to physical contractions, which reduces the size of the final name, and also does things like replaces spaces with underscores, etc. So we're going to use those mappings to try and work back the other way and produce logical names for us. So next step, we can create our model. So the tool's now created for us two interconnected models, a logical and a physical. So here we've got our physical model, which is showing naming faithful to the actual database itself. And it's created, again, using that naming standards template, a logical version with nice business-friendly names. So the next step is to lay out the diagram how we like, so it's easy to understand. And then we can start modifying the model so that it's, one, easy to understand, and two, contains all the business metadata that is useful for our project. So not all the table and column names have been fully expanded by the naming standards template. So the first job is we maybe edit some of those column names and give them proper logical names. So here, apply agency identifier. We could also go through and attach definitions to our entities and columns and textual notes. We can also start applying properties to our modeling objects, and within our data dictionary we can build out a set of properties that we might want to apply and use for classification of our metadata. So there's some built-in properties that we can use, and we call them attachments. So here we've generated some standard properties that we might want to apply to objects. So these security properties have now been attached to our objects and we can populate them. So our standard security information, privacy level for instance, so we can set different drop-down values, internal use only, security impact, attach these properties to our objects. And all of that is totally user configurable, so you can set up your own properties that you might want to apply as a series of standards and reuse those across models. And all that's contained within our data dictionary. So to summarize, we reverse engineered the database and created a physical model and also auto-generated a logical data model. And during that process, we got the tool to create some nice business-friendly logical names based on a naming standards template. We then manually enhanced the model, so we went through and modified the logical names. We added some text to entities and attributes with definitions and notes. And then we added some properties that we could use for classification of our objects, and we saw how we could generate some standard properties and talked about how we could add user-defined properties to objects. For more information, go to idera.com/contact sales.